We are looking at the second part of 2.4, and we are doing linear functions, but with word problems. So our first scenario is that we have a cab ride. It costs $4 and then $1.75 every mile driven. Going to get pretty pricey. So first thing, what is the slope intercept form that we want to be working with? Y equals mx plus b. So that is the form we're working with today, slope intercept form. And anytime we're going to do word problem, we have to define our variables. That is going to be part of your credit. Now, if you just want to use X and Y, you can. And if I was graphing, I would definitely use X and Y. But since we're just doing a word problem, I'm going to use variables that mean something to me. So I'm going to use M and I'm going to use C. Now, if you tell me M stands for miles, you're not going to get full credit. I need to know how many miles they drive, right? So it's got to be the amount or the number of miles. I use abbreviation a lot, amount of miles or number of miles. So you can't just say miles. It has to be something that's quantitative, okay? A number, a quantity. And then C, I did for the total cost. Cost, I should have said total cost. And that is going to be measured in dollars. So the idea is this is my independent variable like X. I need to know how many miles are driven, and then that determines the cost. So independent, dependent. So let's start with the total cost is equal to, well, how much do you pay just to get in the cab? $4. And then we add on to it not just $1.75 once, but $1.75 per mile. So if they drive 10 miles, we have to multiply by 10. So we put that in there. Now, I'm fine with that equation. That is good. You could rewrite it and you could do the $1.75 M plus 4. Addition is commutative, so we're set either way. And there you go. And then I can ask you different things. What would be the cost of 10 miles? You would just plug it in and get that answer. And anytime you're answering, make sure you label. Okay, so here we go. Clay's destination is 17 miles away and he has $30. Will he have enough money for the cab ride? Okay, so you do need to answer the question. So I'm going to show my work. I am going to put the 17 in for M. And the question is $30 enough? That's what we need to know. All right, so the total cost of Clay's ride is 4 plus $1.75 times 17. And this is where you might want to throw it in a calculator to save some time. And what are you getting for the cost? Well, I'm looking at it being $33.75. So if we're thinking about it, it'd be $33.75 for 17 miles. Now, I didn't really answer the question. I'm just giving the information. Does Clay have enough money? No, Clay does not have enough money. Okay, so there's my proof. There's my answer. Don't just say, well, I told you it was $33.75. Make sure you state an answer to the question. Okay, go ahead and let's read about the Jones and their new home. All right, so the closing costs have a set fee of $249, and then they're going to add on 3% of the purchase price. So the more expensive the home, the more money they're going to spend, right? So write an equation to represent the total closing costs. Again, you could do what you want. The closing costs depend on the purchase price. So I'm going to use P, and that is the purchase price. And that's going to be something in dollars. And I'm going to use C, and that is going to be for the closing costs. And again, both of these are measured in dollars. So what would my equation be? My closing costs are the start $249, and then how do I write 3%? Because I'm in, this is $249 in decimal form, so how do I write 3%? 0.03. Remember, you have to move the decimal 2 places. So it's going to be 3% of the purchase price. That's my equation. This is my base. Do you see the idea that this is my rate of change, my slope, times the cost, and then I add on. This is like how I have to start. Okay. That's P?
No, it's like mx plus b.
Oh, yeah. Y equals mx plus b. That is the starting point. That's your y-intercept. All right. The purchase price is $195. So P, the input, is $195,000. The sellers offered $5,000 in closing costs. So if someone's really wanting to sell their house, they can offer to say, hey, if you buy our house, we'll knock down some of the price by helping you. Like, we'll pay this to help you close. Okay. So will this cover their closing costs? So is $5,000 enough to cover what they're going to owe? Now, obviously, they're going to owe for the house and they're going to owe interest and all that stuff on a loan. We just want to know about the closing costs. So the total closing cost would be that initial $249 and then 3% of what the purchase price is. All right, I'm definitely going to crunch a number in a calculator on this one. I'm getting $6,099. That means closing cost is $6,099, which is more than the $5,000 offered, right? So what's that mean? How much will the Jones need to pay out of pocket? Well, wouldn't you take that $6,099 that they owe, take away the $5,000 that they were giving them, and what do they owe? All right, I'm out of room here, so the Jones will pay $1,099. Some people call that out of pocket, like they're paying it themselves out of their own bank accounts. All right, there you go. So we did the math, we have proven it, and we answered the question at hand. So will this cover their closing costs? This was the first part of the question, right? Closing is $6,000, which is more than $5,000 offered. So no, it's not covering the closing costs. And this was the second question. So make sure you're reading it. Okay. We have a 22.5 ounce candle burning at a constant rate of 1 ounce every 5 hours. So 5 hours, 1 ounce is gone. Another 5 hours, 1 ounce is gone, right? Okay. That's your constant rate of change. And we want to represent, read it, the amount of the candle left. Okay. So I'm going to let C stand for the amount of the candle remaining. Amount of candle remaining. And what are we measuring that in? Ounces, which is OZ if you would like. And H, actually H I'm going to put up here, is the number of hours. H is my independent variable. The amount of candle remaining depends on how long it's been burning. What would be my change here? My sort of constant rate of change, or my slope? Positive or negative? The candle's decreasing, right? So my slope should be negative. Can you think of what the slope is? Okay, well, let's try this. Some of you get it. Like, you're losing 1 ounce every 5 hours. And so if you catch it, you might be like, hey, my slope or my rate of change is negative 1/5. I'm losing an ounce every 5 hours. Do you see negative 1 ounce, positive 5 hours? Okay, if you don't see that, how could I get it? If you didn't see that, let's talk about how we could do it. Let's think about a T-chart or ordered pairs, hours, and candle. In 0 hours, I haven't burned the candle. Aren't there 22.5 ounces? All right. And after the first, no, not first hour, how many hours? Let's just go with 5 hours. How much do we lose? 1 ounce. So 22.5 minus 1 is 21.5. Can't I find the slope if I have two ordered pairs? I mean, I could keep going. I could do 10 hours. I get 20.5. So I'll do my slope formula. Y2 minus Y1 over X2 minus X1. And I get -1 over what? 5. So if I wasn't sure what my slope was, do you see how I can sort of start off and reason it out? And I pull those two ordered pairs and I pull my slope. Okay, so here we go. The total amount of candle remaining in ounces is going to be, I started with 22.5 total, and we're taking away 1/5 every hour. It's important that you could have plus and negative, but it's important that we're taking it away. You could have also written it as -1/5 H plus 22.5. That's where we start, how many ounces, and then we're taking that away each time. Okay, so we want to know how long will the candle last. Okay, when the candle is gone, how many ounces are left? 0. Now, I know that's rough, and someone's going to say, oh, it never fully, we're just going to pretend that the candle is completely gone. So when it says how many hours will the candle last, I'm looking for how many hours, but the total amount of the candle is 0 ounces because it's gone. So I'm not plugging 0 in for H. I'm setting it equal to 0 and trying to find out how long that is going to take. I lost my, yeah, there it is. Okay, what do we want to do? Okay, we can subtract the 22.5. Someone else might have added the 1/5 H. It doesn't matter to me. And then you have a calculator, so this is your call. How do you get rid of this multiplication? You could divide by -1/5 and divide by -1/5. And because you can use a calculator, you could do that. Or the other option is to multiply by the reciprocal of -5. Not the opposite reciprocal, but the reciprocal. Either way, what do we get for H? We get 112, is it 0.5? All right, so 112.5 hours for the candle. I don't know how to say it. I think I messed up how I want to say it. For the candle to burn out. Is that okay? Or the candle has 112.5 hours of burning time. Okay, let's talk about John and his potting soil and mulch. These are really, or Josh, and this is great stuff, guys. All right, Josh bought 3 bags of potting soil and 10 bags of mulch. Now this is changing up our system. This one's going to be a little different. So now we have 2 things going on. We know how many bags of potting soil he bought, and we know how many bags of mulch he bought. What I don't know is how much everything costs. See, it says here, write an equation to represent the total cost. So I don't know how much all of this costs. I mean, I can say he has 13 bags, but I don't know it. So I'm going to say that P is going to stand for potting soil, but what about the potting soil? A lot of you want to say the amount of potting soil. I know the amount. He bought 3 bags. What I don't know is the cost per bag of potting soil. I also don't know, I'll use M, and that is going to be the cost per bag of mulch. And then there's a third thing I don't know, guys. I don't know, I'm going to use C, which is the total cost. So there's a lot of things that I don't know. But the big thing is that we're defining our variables correctly. P does not stand for potting soil. It's got to be a number, a quantity, an amount. So it's the cost of potting soil. We know how much mulch you bought. We don't know the cost. So the total cost is going to be 3 bags times the cost. Quantity times cost would be all the money spent on soil, plus 10 times M, all the money on mulch. So if each bag of mulch was $5, that'd be $50 on mulch. And that's equal to my total cost. This looks like standard form of an equation, right? The AX plus BY equals C. All right, Josh spent a total of $40.91, right? The cost of mulch is $2.75 a bag. We are looking for one thing, the cost of potting soil. So C is $40.91. The cost of mulch is $2.75 a bag, and I'm looking for B. So I had to have the information to fill in. 40.91 is equal to 3P plus 10 times 2.75. Okay, so we can crunch some numbers here. Keep my 40.91, keep my 3P, and this just moves it one decimal place, so 27.5. Then I'm going to solve by subtracting 27.5. See what that number is. You could put a 0 there and do some longhand math. I think it should be 1341, but double check me. $13.41? Okay. Then I'm going to divide by 3. So what do we get? Yep, and we're going to round to the nearest penny. So P equals 4.47, and we know it's a word problem, so what's it mean? $4.47 per bag of potting soil. But I am being specific. 1, we're measuring in dollars. 2, it's a bag of potting soil, because not all the potting soil. Okay, last one. Callie has quarters and nickels. Nothing else, just quarters and nickels. Write an equation represent the total value of the coins. Okay. Do you know how many quarters she has? No. Do you know how many nickels she has? Do you know how much money she has? What do you know? How much what? Oh, well, how much is each quarter? I'm going to use that. How much is each nickel? Okay, so let's talk about this. If we're going to do this in dollars, I've got to turn that 25 cents into what? 0.25. And I've got to turn the 5 cents into 0.05. Fabulous. So Q is actually the number of quarters. So amount or number of quarters, and I will take your abbreviations, like not hashtag, pound for number. Number of quarters, and we know each quarter is 25 cents, but we're going to do it in dollars. And N is number of nickels. And so we have to bring this idea of how much the value is. They didn't come out and spill it. We had to do it. And then let's do T for total value of coins. Or you could say, and we're going in dollars here. Or you could have said C for, I don't know, whatever you want to do. Okay, so the total money in coins would be 25 cents for every quarter. I mean, if you have 4 quarters, you would take 25 times 4 and get $1, right? And then we would add on all the money she has in nickels. 5 cents times the quantity. She has 20 nickels, there's $1. Okay, well, let's see what we know. The value of her coins is $5.50, so that's going to be her total money. And she has 17 quarters, so the total quarters is 17. We want to know the nickels. So it's just a matter of plugging it in. You want to make sure that you show your equation, but even if you're doing this another way, please show me what you plug in. So I'm showing this before I start my work. 25 times 17 quarters plus 0.05 times N. You could have the 0 out front if you want. All right, 25 cents times 17. Are we agreeing with 425? Yes? Okay. We're going to subtract the 425, and we get $1.25. So she has $1.25 in nickels. That's what it means. And then how many nickels does she have? Guys, is my number going to be bigger or smaller when I divide by this 0.05? Bigger. It's how many times does 5 cents go into $1.25? All right, what are you getting? 25. So she has 25. Nichols.